There are a large variety of tools available for analyzing your networks and network traffic. In this chapter, we will look at a few of the most widely used. Some you are already familiar with, such as ifconfig, and others may be new to you. It is my hope that by the end of the chapter, you will be familiar with the key tools to analyze network traffic and understand what is taking place on your network. Command line tools. Let's begin with the command line tools. In Chapter 1, I introduced you to ifconfig, IP protocol configuration in Windows. This command is key to retrieving critical information about your network. Let's try it in our Kali Linux. Kali ifconfig. Where 1 is the IPv4 private IP address. 2 is the net mask. 3 the broadcast IP address. 4 the IPv6 address. 5 the MAC address. 6 the loopback or localhost IP address. Ping is one of the most important commands to determine whether another system is live on your network or the internet. Ping will accept either an IP address or a domain name. For instance, to ping hackersarise.com, you simply enter Kali at pinghackers-arise.com. As you can see in the screenshot above, the ping command sends a packet to the domain server for www.hackers-arise.com, and the server responds. In this way, we know it is up and functional. It also responds with its IP address. If we know the IP address of the host or server, we can simply use that IP to ping, such as Kali ping 185.230.63.107. Another handy command line tool is netstat, network statistics. Netstat shows us all the connections coming or going from our system. This can help with monitoring and troubleshooting network connections. In some cases, I have used it to find malware connecting to my system. Kali netstat A. Your system probably looks different, but you can see every connection to your system. There may be hundreds. To display all the TCP connections, you can use the T switch. For all the UDP connections, you can use the U switch, and for all the listening connections, the bell switch, as seen below. If you are looking for a specific connection, you can pipe, see Linux Basics for Hackers, the netstat command to grep and filter for keywords. If you have an Apache web server running on your system, listening for connections, you can check by piping netstat A to grep HTTP, such as Kali netstat A grep HTTP. SS is a similar tool that can display even more information than netstat in a more readable format. When we run the SS command, we get a display of every connection to our system with the local address and port, as well as the port on the peer system. A network sniffer, sometimes referred to as a packet analyzer, protocol analyzer, or network traffic analyzer, can intercept and analyze network traffic that traverses a digital network. These sniffers can be invaluable to the network or security engineer, the forensic investigator, and in some cases, the hacker. For instance, if an application sends passwords over the network unencrypted, the hacker may be able to sniff and view the passwords. Since only a few applications send passwords unencrypted in our security-conscious era, the value of the sniffer to the hacker is a bit more nuanced. For some exploits/hacks, such as DNS or MTM attacks, analysis of the LAN traffic can be crucial to their success, making the sniffer invaluable. Besides, sniffing a target's traffic can reveal what sites they are visiting, their cookies, their user agent, or even their email messages, if unencrypted or you have the resources to decrypt the message. Many tools are capable of network sniffing, including 1. SolarWinds Deep Packet Inspection and Analysis Tool. 2. Dump. 3. WinDump. 4. Wireshark. 5. Network Miner. 6. CAPSA. 7. Shark. In this chapter, we use two of the most popular network sniffer/analyzers, Nmap and Wireshark. In addition, we use Wireshark to dig deep into the NSA's Eternal Blue exploit to understand exactly how it works. Controversial use of sniffers. For over 20 years, the Federal Bureau of Investigation, FBI, in the United States has used a tool they term Carnivore. This tool is used to sniff and analyze the traffic of people suspected of committing crimes. It is very controversial but legal, as it allows the FBI to eavesdrop on network traffic without a warrant. Prerequisites to sniffing. It's critical to point out that to effectively use a network sniffer, your network interface card (NIC) should be in promiscuous mode. This means that your NIC picks up any packet traversing the network. Usually, NICs only pick up packets that are intended for their particular MAC, globally unique physical address. The other critical point to understand with network sniffing is that the standard file format for sniffing is .pcap, packet capture. This means your system must have a library, a bit of reusable code, to put the packets in this format. These libraries are libcap on your Linux system or wintcap on Windows system. Dump in action. Before we examine the powerful GUI-based sniffer Wireshark, let's take a brief look at the command line. Sniffer, dump. Dump was among the very first, 1988, Linux/Unix-based sniffers. Although it may not be the easiest sniffer to use, its versatility and lightweight design make it worth knowing. Dump can be particularly useful if you have to analyze a non-GUI-based system or a remote system where a GUI would be slow, inefficient, and not very stealthy. To start dump, enter Kali dump. As you can see, as soon as you enter the command dump, packets begin to flow across your screen. These packets are largely communication between your Kali system and the LAN gateway. Let's try creating some traffic to analyze. For instance, let's try sending a ping, ICMP echo request, to your Windows 7 system from one terminal and running dump from the other. Kali at ping 192.168.0.114. Kali dump. Let's zoom in on the dump screen so we can see detail there. As you can see, dump displays the protocol, ICMP, and the type, echo request and echo reply. If we want to capture the output to a file where we can analyze it at a later time, we can use the W option, followed by the file name. Kali dump wmyoutput.cap.
We may want to filter out all the traffic except the traffic coming back from the Windows 7 system. Dump, developed by researchers at the Lawrence Livermore National Laboratory in Berkeley, California. Running BSD Unix utilizes the Berkeley Packet Filter (BPF) format to create filters. We can create that filter for the Windows 7 IP address by entering Kali dump host 192.168.0.114. Now you can see just the traffic coming and going to the Windows 7 system as we have filtered out all the other traffic. Now, let's connect to the Apache web server on our Kali machine from your Windows 7 system. First, start the Apache 2 web server built into Kali. Kali system till Apache 2 start. This starts your Apache web server. Next, start dump again on your Kali system. Kali dump host 192.168.0.114. Now, open a browser on your Windows 7 system and navigate to the Kali system IP address. You should begin to see packets appearing in the dump terminal. Note that we can see the three-way TCP handshake in the highlighted polygon. You can see first an S flag, then an SA flag. Dump represents the A or ACK flag with it, and then a dot flag or written. Another way, SSIN/ACKCK. This filter displays traffic coming and going from our Windows 7 system. If we want a filter for just the traffic coming from our Windows 7 system, we can create a filter like Kali dump src host 192.168.0.114. Now, we are only seeing the traffic coming, SRC, from our Windows 7 system, 192.168.0.114.
What if we wanted to filter out all the traffic except those going to a particular port on our Apache web server? Let's try to filter out everything except traffic going to port 80, HTTP. If we use the VV option, very verbose, dump will decode all the IP and TCP headers, and the user agent can often be used to identify the user. To get these results, we could write a filter such as Kali dump VV DST port 80. Filter by TCP flags. What if we wanted to see only the traffic with SYN flag sets on it? We could create a filter like this. Kali dump TCP flags equals TCP SYN. Of course, we can create a filter for each of the TCP flags, such as Kali dump TCP flags equals TCP app. Kali dump TCP flags equals TCP fin. Kali dump TCP flags equals TCP RST. Kali dump TCP flags equals TCP PSH. Kali dump TCP flags equals TCP URG. Combining filters. Dump enables us to use filters together using a logical and, or a logical or. So, if we wanted to filter for a particular IP address and TCP port 80, we would create a filter such as Kali dump host 192.168.0.114 and port 80. We can also use a logical OR, such as Kali dump port 80 or port 443. If we want to see all the traffic except that traveling from a particular IP address, we can use the negation symbol, or not. Kali dump not host 192.168.0.114. Filtering for passwords and identifying artifacts. To filter for passwords in clear text, we could build a filter for various ports and then use egrep to search for strings indicating logins or passwords. Kali dump port 80 or port 21 or port 25 or port 110 or port 143 or port 23, la egrep, IB5. Pass equals PWD equals log equals login equals username equals PW equals pass equals password equals. Finally, if you want to filter for just the user agent, an identifying signature of the user and their browser, we could create a filter such as Kali dump VVLS grep user agent. Wireshark now opens and asks you which interface you would like to listen on. If you are using a VM, select the F0. Select the wireless adapter if you are using a physical machine with a wireless adapter. Probably WLAN 0. Usually, you can determine which adapter to select by activity level. The most active adapter is likely the one you want to use for sniffing. Now, Wireshark begins capturing packets from your network interface and packaging them into the .pcap format. PCAP is the standard file format for packet capture. You find it used throughout our industry in such products as Snort, AirCracking, and many others. You see three separate analysis windows in Wireshark. The top window, labeled number 1 in the screenshot below, is known as the packet list pane. You should see color-coded packets moving in real time through this window. The middle window, labeled number 2, is known as the packet details pane. This pane provides us with header information from the selected packet in window number 1. Finally, window number 3, packet bytes pane, provides payload information in both the hexadecimal format to the left and the ASCII format to the right. In general, there is way too much information here to do an effective analysis. Packets are flying by hundreds or thousands per minute. To use Wireshark effectively, we need to filter the traffic to see only Those packets of interest. Wireshark has a simple filtering language that you should understand to use effectively and efficiently in any investigation or analysis. The packets flying by our interface are of many different protocols. Probably the first filter we want to apply is a protocol filter. Remember, TCP/IP is a suite of protocols, and we probably want to focus our analysis on just a few. In the filter window, type TCP. You notice that it turns green, indicating that your syntax is correct. It remains pink while your syntax is incorrect. Now, click the arrow button to the far right of the filter window to apply the filter. When you do, Wireshark filters out all traffic except the TCP traffic. You can do the same for just about any protocol, such as HTTP, SMTP, UDP, DNS, and many others. Try out a few and see what traffic is passing your interface. If we want to see traffic only from a particular IP address, we can create a filter that only shows traffic coming or going from that address. We can do that by entering at the filter window IP.address ==. Note the double equal sign in the Wireshark filter syntax, similar to C assignment operator. A single equals does not work in this syntax. In my case here, I want to see traffic coming or going to IP address 192.168.1.107, so I create a filter like so. IP.address == 192.168.1.107. Now, you see only traffic coming or going to that IP address. Now my analysis is narrowed to a single IP address of interest. We can also filter traffic by port. If I want to see only TCP traffic destined for port 80, I can create a filter like that below. TCP.port == 80. If we aren't sure what field we want to filter for or how to create the necessary filter, we can click on the expression tab to the far right. This opens the expression window like below. To the left of this window is the long list of fields available to us to create filters. These are hundreds of protocols and the protocols fields. You can expand a protocol and find all of its fields and select the field of interest. The upper right-hand window includes the relation choices. These include, we can now create a filter by simply selecting a field in the left window, a relation in the upper right window, and a value in the lower right window. Values are very often 1 or 0, meaning they exist or do not. For instance, if we want to find all TCP packets with the RST flag set, we would enter TCP flags.rst == 1. In some cases, rather than examine all the packets of a particular protocol or traveling to a particular port or IP, you want to follow a stream of communication. Wireshark enables you to do this with little effort. This technique can be useful if you are trying to follow, for instance, the conversation of a rogue disgruntled employee who is trying to do damage to your network. To follow a stream, select a packet by clicking on it and then right-click 55 PAGE. This opens a pull-down window like that above. Click Follow and then TCP Stream. This opens a window that includes all the packets and their content in this stream. Note the statistics at the bottom of the window to the far left, 5,796 bytes, and the method of displaying the content, ASCII. Statistics. Finally, we may want to gather statistics on our packet capture. This can be particularly useful in creating a baseline of normal traffic. Click on the Statistics tab at the top of Wireshark, and a pull-down menu appears. In our case, let's navigate down to the IPv4 statistics and then all addresses. As you can see above, Wireshark has listed every IP address with activity and some basic statistics for each IP address. Sniffers, network analyzers, protocol analyzers such as Dump and Wireshark are essential tools for understanding what is taking place on your network. the better you understand how these tools work and how they can help you analyze your traffic, the better you will be as a network engineer or hacker.